Hey everyone, welcome. This is the Routing Loop, your weekly dose on the best of AWS networking. And today we have just that the best of AWS networking with Tom Adamski. And my name is Sid. I'm a principal solutions architect here with AWS. And today we are going to talk about hybrid DNS, which we were talking about last week, by the way. So this is a continuation of that. There's so much good stuff to talk about that we said, hey, let's do it one more week, and let's talk about some more details. And Tom's gonna take us through that. Tom, do you wanna just share what we discussed last week and what you're gonna talk about today?
Yeah, thanks, Sid. I might do a little bit of a recap of what we discussed last week. We did mostly outbound resolver. So that's a case where you need to resolve DNS on premise. You have a private domain on premise, and then you want to allow your VPCs, your AWS environments to be able to reach to that internal zone. Today we're going to talk about the other direction. So what if you have things on premise then and that you want to expose AWS hosted private hosted zones that maybe live in one of your VPCs? How can you get access to them? I also, if we have time, I want to talk about some of the let's say suboptimal patterns. I wouldn't call them anti-patterns because they work, they solve a problem, but we have now slightly better ways to solve some of the problems that come up. So it should be interesting. We're going to do whiteboarding and a demo. So we don't have slides today. Some of you probably will be happy about that. So we'll just whiteboard. We'll do a demo. Um,
Cool. So just to recap, Tom, so we have a situation where customer has on-premises data center and they're connected to AWS VPC, like AWS infrastructure, and they have a client on their on-prem which wants to access maybe an EC2 instance, right? And now the EC2 instance is part of a VPC and it has its own DNS name. The question is, how does the on-prem client know how to resolve that DNS name? Because that DNS is hosted somewhere in AWS. So that's what
yep,
you're going to cover
that's
today.
what we're going to do. Yep. Well, I'll whiteboard the whole scenario, and yeah, we'll show you end to end how it works. And yeah, throw your questions in the chat. We'll happily draw whatever you want to talk about. I already see some updates in the chat. Hirings. I love slides. We don't believe you hirings. I don't think that's true. I don't think you love slides. I think whiteboarding is the way to go. We'll see.
Well, we do a great job at building slides. If you see, I think networking reinvent sessions or like even others like reinforce or whatever it might be, the slides with like thousands of animations. I think we raised the bar on that as well. So, but
Yeah,
then whiteboard is classic. So,
yeah. Before we jump in, actually talking about events, Sid, I know you're heavily involved in the New York Summit, at New York AWS Summit. That's a free event, so anyone can sign up and join and see what's going on and chat to experts, join sessions. Anything exciting you can share from what's coming in that event, maybe especially on the networking side?
yeah, absolutely. So we do have two sessions which we are running at New York Summit. New York Summit is on July 15th at the Javits Center in New York City. So we have one session on hybrid networking, focusing on Cloud WAN and how you can use Cloud WAN to build global networks as well as hybrid networks connecting to your on premises. So we'll basically focus on the fundamentals of Cloud WAN, how you set it up, and as well as service insertion, and how can you inspect your network, especially as you're routing between segments globally and easily, right? And the second session, we will be covering VPC lattice, right? So application networking, how you can use VPC lattice to build, cross VPC, cross account application networks with policy-based routing, authentication, authorization, and all that fun stuff. We did recently announce Lattice. Some people like to call it. It's a blend of private link and Lattice, VPC Lattice, using resource endpoints. So we will talk about that as well in that session. So a lot of fun stuff. It's a builder session, which means you get to not just learn about these services, but also get hands-on to these services. So definitely come join us and bring your laptops so that you can get that live interaction with the services.
Cool. Yeah, that sounds fun. And I don't know if Platis is marketing approved, but I like it. Oh,
Yeah, when I was at Reinforce a couple of weeks back, and then I spoke with a couple of customers, and they're like, "We're really excited about Platis." I'm like, "What's that?" It's like that's private link and lattice. So I think it's a term which is catching the trend. So not marketing approved, but I think it's just cool.
yep, I love it. All right. Sid, I think if you want to share the screen and we can start drawing and we can start talking about what we have in here.
Absolutely. Yep, the screen's visible now.
All right. So we're going to go back to the same environment we had last week where we had a workload VPC in the 10.0.0 range. Maybe let me zoom in just a little bit closer. And then we have a VPC that's called on-premise VPC, but we're pretending that this is the on-premise environment. So let's draw that out very quickly on our whiteboard. So we will have, this is our workload VPC. And then we have our on-prem environment, on-prem. Yeah, it is represented by another VPC, but just imagine it's another environment. And then the IP space, keeping it very simple, 192.168 for on-prem, and then 10.0.0.0/16 for our workload VPC. On-prem, we also have a DNS server. That was in the 192.168.0, I think it was .7. And that DNS server had example.internal domain. That's a domain that only this DNS server is aware about, and only on-premise environment can talk to that DNS server to be able to resolve records inside of that example.internal. So you could do a lookup on www and on a bunch of different host names, and those would come back with some IP addresses that this DNS server was aware of. The way we connected these two environments is we use Transit Gateway. So TGW in the middle. It really doesn't matter what's in the middle here, since we're pretending the right-hand side is on-premise. But so this is just an attachment to a Transit Gateway, attachment to the Transit Gateway. We then had a client in here, so just an EC2 instance. And we know that inside of the workload VPC, by default, a client would send all of the DNS queries for any destinations to the .2 IP address or the Amazon provided DNS. So that is .2, Amazon provided DNS, also called Route 53 resolver. It goes by many names. And then that resolver would take care of, okay, where is the query for? What's the domain that you're trying to resolve? Maybe you're going to GitHub. Now, and it's a public domain, I'll come back and give you the IP addresses for GitHub. But what we were trying to do and what we achieved last week is we allowed the clients to be able to send DNS queries for example.internal and forward those queries all the way to the DNS server. And I'm going to maybe draw that in the green. So what we've configured is an outbound endpoint. Outbound endpoint is ultimately a network interface or multiple network interfaces with IP addresses that the Route 50 resolver can use to forward the DNS queries to on-premise. It can't directly forward from the .2 IP address. That's not an IP address that is routable. It could be used as a source or a destination of traffic. So that's why we need this outbound endpoint. And then what would happen, the client would send a DNS query. Actually, let me use a color here. The client would send a DNS query to .2 for www.example.internal. On the resolver, we would configure a rule that would say anything star.example.internal forward to on-premise to that IP address 192.168.0.7. So flow was happening. We get a query for www.example.internal. the rule kicks in and we know that anything ending with example.internal should be forwarded to on-premise. We can't forward directly. There's no way to do that. So the resolver would use the outbound endpoint to send that traffic through and get it to the DNS server. And then the DNS server responds with the appropriate IP addresses. The response goes back to the endpoint that the traffic came in from. The endpoint has an IP address from the workload VPC, so as long as this routing, the DNS server can reach the endpoint, and then the response comes through to the client. And then we get an answer of, okay, www.example.internal is some IP address. So that's a very quick recap of what we did last week. That video is available on demand. If there's any questions on this still, feel free to ask. We can answer. But today I want to focus on the opposite direction. So
So,
what we
Tom, before we jump to the opposite direction, one quick question which we have in chat, I think is an important one. So if you modify the DHCP option set of the VPC to point directly to the on-prem DNS server, you basically break DNS. So that's the question.
Yeah, you wouldn't break DNS. I mean, let me draw that out and maybe we do it in red. So you could change the DNS settings on the whole VPC, where you would say, this VPC, I don't want to use the default settings for DNS resolution. I want to send traffic straight to this DNS server. The problem with that is now you created a dependency for all of your DNS resolution, right? So not just for example.internal, say you're resolving GitHub, right? And the VPC has a path to get to the internet, to get to GitHub somehow. It doesn't need to rely on premise. So if, say, my connection here got severed or the DNS server on premise has an issue, but that's your destination for all of your DNS resolution, you can't go to GitHub. All of your traffic is going to get dropped because none of the DNS resolution can resolve. So that's why we don't recommend doing that. We don't recommend you switching DHCP option sets to point to some other DNS server. The recommended approach is point to your resolver inside of the VPC and then do any forwarding you need. So you could even have a star and say, I want to forward everything to my on-premise. And at least then what's going to happen is the star will take over. So all of the public DNS will go on-premise. That's also still a risk, but at least any private zones. So we'll talk about private zones in a second as well. Any private hosted zones. So let me just do that. Let's say we have a private hosted zone. A private hosted zone is a private DNS name or DNS domain. If someone wants to throw in a name inside, we'll use that as an example. If there's a funny one, we'll use that. But ultimately, that gets attached to that resolver in a particular VPC. So even if I have forwarding for a star and everything should be forwarded, but I have a private hosted zone that's more specific, that will take precedence. So I'm not breaking resolution of private hosted zones inside of the VPC. That's still going to work.
Yeah, I think that was a big one, right? Where if you point everything to your on-prem DNS, the private hosted zone resolution breaks. Like that's the only thing which breaks.
Yep.
Everything else will work.
Yeah, there's also so private hosted zone resolution breaks. There's also some cases where and maybe let me draw that a little bit at the bottom as a sidebar. So sidebar here is, let's say we have a VPC and it has two availability zones. And we use a service like EFS, Elastic File Storage. So that's a storage service with mount points where you'll be sending a lot of data to and from, right? So this is the way it's presented inside of the VPC, and this is AZ1, AZ2. And let's say you have a bunch of instances here that you want to mount to the storage and a bunch of instances here. Both of these IP addresses or both of these endpoints will appear as an EFS hostname. So in your configuration on each one of the instances, you would be saying, hey, mount to the CFS hostname. And it would be pretty inefficient if by accident the instances in AZ1 ended up mounting the IP address of the EFS in the other AZ. Right? That's not a great experience because one, you just added 2 milliseconds, right? Because the AZs have to be far enough away from one another to provide resilience in case of even natural disasters. So they would be 60-ish miles away from one another. That means around 2 milliseconds in between. So immediately adding 2 milliseconds of latency. And then on top of that, there's a charge for data crossing AZs. So you could have mounted locally to the EFS endpoint in the same AZ, but if you just did the regular DNS lookup, you would get back both IP addresses, and you might end up with the mounts happening across AZs. Now, if you're using Route 53 resolver, so .2 resolver, and everybody is going to go to the resolver to say, hey, I want to talk to that EFS hostname. The resolver for EFS specifically, for that hostname, it will have AZ aware responses. So it will know which AZ the request is coming from, the DNS query. So these are all your DNS queries, DNS. And it will go, oh, instances 1, 2, 3, and 4, you guys are in AZ1. I'm going to give you this IP address. So your mounts are local. You're not crossing AZs. You're not paying for cross AZ, even though they're using the same hostname. These guys, 5, 6, and 7, 8, they'll be pointed to a different IP address. So it will return just the IP address of the AZ you're in. So it has that AZ awareness. And there's a few other services where that's also applicable. NLB has an option where you can enable AZ aware responses on DNS. There might be a few others. That is super critical. If you're not using the Route 53 resolver and you decided, hey, I'm just going to talk to my DNS on premise, there's no AZ awareness, right? You're just going to get back both IP addresses, and it's a spin the wheel. I might end up mounting this one, this IP or this IP. This is going to be super suboptimal. You're going to be paying a lot for something that could have been free from the data cross AZ data transfer charges and the extra 2 milliseconds.
Yeah, that's a great point.
All righty. Back to our regular programming. Do you have any ideas of private hosted zones? Someone take the bait and try and submit anything in there?
No, didn't get anything.
Damn, come on. Okay, I'm gonna make something up.
Well, we can always ask Amazon Q to generate something funny.
Give it a go. Okay, let's see what it comes back with. Then we'll have our private hosted zone attached to a VPC, and then what we will want to do is allow our DNS server to be able to send a query and get an answer for this private hosted zone. I'm going to put let's call it loop.internal for now while we wait for, and then we'll put some records in there, maybe again, www, and we'll make that 555. And then what we will want to do is allow somehow the DNS server in on-premise environments to be able to send a query and get an answer for this internal only private hosted zone that only this workload VPC can see. Okay, so we're going to go to Route 53. Look at the hosted zones. I have a bunch here that you can ignore. We're going to create a completely new one. We're going to call it, what did I say, loop? Node internal.
Okay, I got a few funny ones, so you can probably use those.
Okay, go on.
All right, I'm gonna share a couple. It's just funny. One is Control Alt Delete Me dot local. Other one is definitely not production dot local.
I think I'm going to struggle. I think I'm going to struggle with the spelling. I think that maybe we stick to the 4-letter name, because then I know I'm not going to mess up the spelling. I'm dyslexic, so the longer the name is going to be, it's going to be a disaster for me to make sure.
Yeah, everything is long, obviously, to make it funny. But I
Yeah.
think
Okay, we're sticking to loop then.
yeah. There's one more. It's funny. 404 network not found. Not internal.
Yeah, it's not too bad actually. Yeah, the
Yeah,
404 is not bad.
yeah.
Okay, we're sticking to loop, keeping it easy, simple. Okay, which region were my VPCs in? Oregon. So I'm gonna attach this private hosted zone directly to a VPC. And I have my workload VPC, which is the one I'm going to use. On-premise VPC, we imagine that's not a VPC, so it's like I can't use it. So I'm going to attach it to the workload VPC and create that hosted zone. So what's happening right now is this loop internal private zone is created, and it's being associated with just one VPC, with the workload VPC. In real life scenarios, I would associate this private hosted zone probably with all the VPCs I want to create this view for. Right, so if all of my VPCs, I have 10, 20, 100 VPCs, they all need to see looped on internal records. I will need to associate that zone with every single VPC. And then we can chat in a second about different ways of doing that, because there's scalable ways of doing that, and there's ways that are painful. Both technically work, just some of them are easier. Okay, so as this is creating and associating, we want to create a record. So right now it just creates the generic name server and SOA records, which are always there. But we want to create our www record. So www loop and internal, return an IP address, whether we say 5555, so it's easy to spot that it's something weird. And then create records. Okay, so now we have the www loop internal, a single record pointing directly to 555. All we need to do is just be able to resolve it. So if I go into my EC2 section, and we'll connect to the instances, we go on the workload instance. So that is the actual instance that's inside of the workload VPC. Connect to that one. Can do it in the browser using instance connect endpoints, and then clear. And can I do a dig www.loop.internal? Okay. So this instance can see records inside loop.internal. If I do go into my home machine, so this is just my MacBook, I can't resolve, obviously, if I do dig www.loop.internal. I get nothing. That's a non-existent domain. It's not a public domain. There's no way for me to see it. So if I were to connect to our on-premise instance or DNS server, and we'll try and do a DNS lookup. www.loop.internal. I'm super glad I selected loop, because now it's super easy to type. That doesn't work, right? It's a non-existent domain. No responses coming back. So now we need to figure out, okay, how can we get the server to be able to get answers from that domain? And one thing that often customers would think about is, hey, could I just forward my queries for that domain to .2? Why could I do that, right? Can I just have this DNS server reach the .2? Typically, the .2 IP address is not something that's reachable from outside of the VPC, and it shouldn't be returning responses as well. So that's not the right model to follow. So you need to find something else that you can target that's in the routable space of the workload VPC, that also has visibility to this private hosted zone that's attached to the .2 resolver. And the way we would do it is we would set up another endpoint. So we had an outbound endpoint. This is going to be an inbound endpoint. And an inbound endpoint is just a way to get into the VPC, and that inbound endpoint has visibility of everything that the .2 has visibility of. So we'll see all of the private hosted zones that we associated with the VPC. So what we can do is go ahead and create that inbound endpoint. So we're back in the Route 53 section. We'll create an inbound endpoint, call it inbound endpoint. Forwards query to S3 resolver, yeah, default. The VPC it's going to be in the workload VPC, right? So it needs to sit in the workload VPC. We need to have a security group. I hope that security group's working. We're going to check it in a second. Let's make it v4 for a second, and then just the regular DNS 53, no DNS over HTTP or the FIPS version. We're just keeping it simple. We need to select the availability zones that the endpoint is going to be in. We can put it in the private subnets and then auto-generate the IP addresses. I only have one AZ. I think I might have only one AZ, so I'm going to put both in the same AZ. Yeah, at home, when you're following at home, make sure you have multiple AZs. I try to keep things simple for the demo sake, so I only have one AZ. So both endpoints will end up in subnets that are in the same AZ.
So Tom, this inbound endpoint, it's pretty much like a proxy, right? Which is basically sitting in the VPC, has access to the private hosted zones, gets the request from on-prem DNS, and just basically proxies those requests,
Yeah,
gets the response, and then send it on-prem.
yeah, you can think about it that way as a proxy. It's not exactly a proxy, but it's receiving DNS queries. It's able to forward those DNS queries to something that can respond to the DNS query you have, and then return the answer back to the client. So from a flow point of view, we'll configure the DNS server to send the DNS query to the inbound endpoint, and we'll see that if that happens, if I hit the inbound endpoint, I'll be able to resolve www.loop.internal. We can think it's all good to go. Let's have a look at the IP addresses we have, and let's actually, one other thing we want to do is check that security group. So it made us add a security group. Where is it? I want to make sure that the security group is actually allowing the traffic we want. Security groups. Okay, let's see. Inbound rules. Okay, it looks like I already played with it. I have all UDP traffic allowed from 192.168.0.0.24. Again, don't do this at home. Just make sure you specify the port that you're allowing. I'm keeping it broad here, just in case
So
we would be doing other testing.
yeah, it'll just be 453, right? UDP 53.
Yeah, it just be port 53. Yeah, I tend to be very generous in my test environments with what I open, especially if it's just private IP addresses as sources, because then I do a lot of different testing and I want to make sure I don't have to keep opening up ports. But yeah, wouldn't recommend doing that in production. All right, so I think we should be good. Let's see, let's test it out. Let's grab one of these IP addresses. Let's use this one. And where is our, so this was our on-premise instance, right? Previously, it couldn't resolve loop-down internal, but we can try and do the same resolution and then point it at the IP address of the inbound endpoint. So this at and the IP address basically specifies to the dig command that instead of using a local resolver on the operating system you're on, use that other IP address as the destination for your DNS query. So that's going to be a way for us to validate that this is actually working. So if I do a dig, okay, that's working nicely. So you can see I get a response back from the IP address that I sent it to, and this is the IP address of the inbound endpoint. That inbound endpoint has access to all of the private hosted zones associated with the VPC that it's in, and it can provide me an answer. Right, so that's working nicely. Now, what we often see is in larger environments, say you have 100 other VPCs. Right, so say 100x VPCs, and maybe some of them have private hosted zones that you also want to be able to resolve from on-premise. So what would you do? So if we call this private hosted zone 1, and then we say that here maybe we have private hosted zones 2 to 10, like there's 10 private hosted zones across those VPCs. How can we make them visible to on-premise? Right. One option is to have an inbound endpoint in every VPC where a different private hosted zone is. So maybe this VPC has private hosted zone 2, this has private hosted zone 3, 4, 5, whatever. That's one option. So we would have to create a network path to these VPCs and then create inbound endpoints in every single VPC. Technically, that would work. It would end up being pretty pricey because there's an hourly fee for each endpoint. So ideally, what you want to do is, if this workload VPC is the VPC that will have the endpoints, just attach these private hosted zones to the same VPC. A VPC can, I can't remember what is the quota limit, but I think it's in the hundreds, at least, and it's a soft limit of how many private hosted zones you can have as part of the VPC. So you want to make this VPC have a view that has access to all of the private hosted zones. So maybe it would be loop 1, loop 2, loop 3, whatever the names are. As long as this VPC can see it, the inbound endpoint can see it, and then as anybody that can reach that inbound endpoint from on-premise will be able to do a DNS resolution against those records.
So, Tom, does it make sense to create a separate dedicated VPC just for this inbound outbound endpoints and not put any workloads in it?
I haven't seen many customers do it because ultimately it really doesn't matter that
Well,
much. I don't know if you've seen differently.
it's
There's
just
an element of elegance in there, I would say, but I haven't really seen like a strong use case of why would you do it other than just
also a
stick
security
VPC in.
thing, right? Also a security thing because this workload VPC, now if you're sharing private hosted zones with it, it has access to all the private hosted zones. So
Yeah,
that's sort of a security thing. I mean, not like why is it workload special that it gets access to all the private hosted zones? I mean,
yeah,
that may be a security thing.
yeah. This could be a shared services VPC, right? Usually
Yeah.
that makes sense if it's a shared services VPC where you have a bunch of things that everybody needs to access. Active Directory, some tooling, other resources in that VPC. And then it kind of makes sense that that VPC also has a visibility of all different private hosted zones. I think where this gets complicated is if you were overlapping some of the private hosted zones, right? So you were using the same domain because private hosted zones, each one has a unique ID regardless of the domain that you create, right? So I could create another loop here, right, in my hosted zones. I could create another loop.internal as a private hosted zone. I think I have to associate it with a VPC. Let me associate it with another VPC in a different region for a second. So it's totally letting me do it, right? It's not an issue. I have now two loops done internal. They do have unique IDs. So the thing that makes the zone unique is that ID here. Can I see the whole thing? As I make the screen too big, yeah. You can't see it all the way here, but each zone has a completely unique ID, and that's what differentiates it. So the hosted zone name can overlap. So I can have two loops internals and maybe two different VPCs required to have a different view for a loop internal. There's still going to be unique zones. So at that point, if I I don't think I can even attach the same uh, hosted zone name to the same VPC because that's going to be a clash. So
Yeah.
in
You
that
won't be able to do
scenario,
it.
yeah, at that scenario, you will not. It doesn't make sense to have them all in one VPC. I don't see many of those cases. I don't think it's a good idea to try and have that very segmented view of the same domain, but there are some cases where that's something that's done.
Yeah, I mean, duplicate domains, duplicate IP addresses. If you do that, you deserve pain anyways.
I don't know.
We have a comment
Yeah,
from
sure.
Tech Fuel saying they've created transit VPCs in the past and associated all private hosted zones with that and set up inbound endpoints in that.
Yeah. There is an interesting pattern, and let me see. We still have time, so there's one other pattern that I want to explore here. Now that we understand the outbound and inbound endpoints, it will be less of a demo, but probably more of a discussion. Because what I've seen a lot of customers do is now imagine we have all these private hosted zones, and let's say they're not overlapping. So we have loop, maybe app one, loop.internal, and so on. So let's say we have like a bunch of different app two, loop.internal, and so on, up two, up one, up three, up four. So now we shared all those private hosted zones with this workload VPC, or let's call it like a shared services VPC, so that on-premise can see all of the domains. Awesome. Now, what if that one of those VPCs needs to see app1.loop or app2.loop? right? What if we want the VPCs to be able to also mesh their view of private hosted zones, because they're all unique, and we want to do the sharing across. Like, it becomes pretty complicated because let's do another sidebar. Let's say we have 3 VPCs, VPC 2, and then VPC 3. And this one has private hosted zone 1. This one has private hosted zone 2. And this one has private hosted zone 3. So now inside this VPC1, I can resolve everything that in private hosted zone 1, let's say up1 loop internal. So all of that works, but then maybe this is up2's loop internal, and VPC1 needs to be able to resolve that because there's some communication path I've set up. So what do? So now I have to attach this private hosted zone here, right? And maybe I need to too, so I also need to attach it here. And maybe it's a full mesh, so everybody needs to see all of the private hosted zones. It just becomes, this is just 3 VPCs. It just becomes pretty complicated.
Yeah, I can see this scaling so well with 100 VPCs.
Yeah. And to add to it is the way you do it is you can't do it in the console. That cross-account private hosted zone sharing, there's a set of API calls where you have to run an API call to kind of share the private hosted zone across, and then it has to be accepted and attached on the other side. It's a little bit cumbersome. Like if you have infrastructure as code, you can pull it off and it will be fine. But if you're not really good at that, you're going to have a hard time doing all this sharing, and it's just going to become messy. So one pattern that we saw customers do, and I'm not recommending that pattern, I'm just saying that's something that we're seeing, and I'm going to tell you a better pattern, is customers would have the shared services VPC. They would all associate their private hosted zones to that one VPC. Inside this VPC, they would have an outbound endpoint and then an inbound endpoint. And then they would set up rules for each VPC that would say anything star dot loop dot internal forward to inbound. So what they did with this is, say I have a private hosted zone. This private hosted zone is up1 dot loop dot internal. Right. So my rule is less specific than the private hosted zone I have. So if the query is for up1 loop internal or www.up1.loop internal, it will come from the private hosted zone. But for anything else, so maybe I'm querying up2, up3, the rule is forward to internal. And this rule set, all of this, is going to be applied to every VPC. So just grab it and copy. Right, everybody's going to have it now.
Tom, would it be to the inbound or to the outbound?
To the inbound. So it would be via the outbound. So what would happen is...
Oh, yeah, via the outbound. Okay.
Yeah,
Okay.
so what would happen is this would, if we follow a life of a query with this model, I'm in here, I'm sending a query for up2 dot loop dot internal, right? It's not up1, so this zone is not used, but there's a forwarding rule that says this should go to this inbound endpoint from the outbound endpoint. So we take that query, we send it to the outbound endpoint, it jumps through to the inbound endpoint, and we know the inbound endpoint can see all of the private hosted zones that are associated with this VPC. And we're assuming that everybody associated their private hosted zone with this VPC, and up2 is this guy. So now we can get the answer. So if the question was who is www.up2.loop.internal, we can get that answer because that zone is associated to this VPC, and then we get the answer back. So from a operational point of view, it's a nice pattern, and there's a lot of customers that actually have adopted that pattern. There are some kind of potential challenges with it. And I can list out the challenges. So number one is you're adding latency to the query, right? So you're having to, it's not resolved locally as you are in the VPC. You're now having to hit infrastructure that's doing all the forwarding, getting you to the outbound endpoint and forwarding you to the inbound endpoint. All those are different infrastructure components before you get to the answer. So I would say one is latency, our potential challenges with this. Two is lack of AZI or AZ independence. What I mean by that, then see if I can spell. What I mean by that is usually you would have multiple outbound endpoints and multiple inbound endpoints in different AZs. That's how you keep this thing highly available. But you can't control which way the traffic is going to go and which outbound endpoint is going to get used for what. So what's going to happen is you send the query, maybe your instance is in AZ1. It gets to the infrastructure, it bounces around AZs potentially, so it can hit AZ2, AZ3, AZ5. You will get the answer if everything is working, but if there's some issue with one of the AZs, so I don't know, AZ3 has an issue, there's no guarantees that even though your instance is in AZ1, you might accidentally bump through AZ3 and you'll never get the response back because there was some issue there. And then the third challenge of this is cost. Right, so you're paying for the queries passing through the endpoints, also outbound and inbound. Whereas if you were to resolve something locally on the resolver, there's no kind of charges there. So those are the three main downsides of it. So
So
even
we
though
have
it,
a
Mhm.
so we have a question which intuitively would make sense, but it doesn't work. So I'll let you explain why. So instead of the inbound, can the outbound endpoint not send it directly to .2 of the shared services VPC?
So I think it's the same problem. You still would have the AZI switching. It might self. I think it's technically will work. I can't remember if I don't think I tried it myself, but I think folks have tried it and this technically works. But you're back in the same boat of you still can cross AZs. There's still at least the outbound endpoint charges, and then there's a limitation of how many queries per second you can send to Route 53 resolver, which we didn't talk about. So when you're sending between the endpoints, you have 10,000 queries per second per network interface, so per one of those ENIs, so per IP address. So if you can add additional IP addresses or additional network interfaces, and then you keep increasing the queries per second, when you have a thing sending traffic to the resolver, if that's an individual component, that can only do 1024 queries per second. So you're running a risk here of hitting the limit on the queries per second when you're hitting the resolver from an individual component or individual ENI, versus if you're using the interface endpoints for outbound and inbound, you actually have higher speeds. At the same time, so we wouldn't recommend this. I know a lot of customers are doing. I know it's solving. In some cases, it's super hard to, that meshing. We didn't. I left. So that meshing that we're looking at earlier, it gets super complicated at scale. So this is a way where you could actually make your life a little bit easier. I think the bit that we would recommend to look at first is using profiles.
Yeah. So before we jump to
Oh
profiles,
yeah.
just a quick follow up. TechFuel is asking, but .2 is also an ENI in every subnet. .2 is not an ENI in every subnet. It's just one IP backed by a highly available service, which is
Yeah.
Route 53 Resolver.
Yeah, you can think about the .2 as like something that even lives on a physical instance, kind of like the instance metadata, right? When you're talking to instance metadata, there's a 169.254 IP address, and you can get some info about the instance when you hit that instance metadata endpoint. That has a link local IP address, but that's not something that lives in the VPC. The .2 resolver has an IP address, a logical IP address from the VPC range, but it also has this 169.254, I think it ends with 53 IP address. So that is, you can think about it more as like a link local thing where it triggers an action on our end to answer a question for the DNS query, but it's not actually a network interface inside of that VPC. That's why it kind of behaves weirdly and you can't really reach it from outside of the VPC. And yeah, that's why the endpoints are necessary in the first place, purely because that .2 is not an ENI.
Cool.
Okay, so let's talk about profiles. I think we launched that maybe, it's been a year out, maybe longer than a year now. So Resolver profiles allow you to create a central profile. And in that profile have a bunch of settings for your DNS. So here you can add private hosted zones. So maybe those would be the ones 1 to 10. You can also add any other DNS settings. So if there's any forwarding rules to on-premise, you can add in here, forwarding. Maybe DNS firewall, that's something you want to enable. And then there's a set of pretty much all of the Route 53 resolver settings that you can imagine, you can configure through the profiles. So you create that profile with all the settings you want, and then you share that out using Resource Access Manager to your individual accounts or to your organization. And then everyone in your organization, every VPC in your organization can associate a profile with their VPC and get a view of all of the details in that profile. So all of those rules will then apply to the VPC instead of you having to like deal with independently with, okay, every private hosted zone requires a separate association. Every DNS firewall rule needs a separate association. Any forwarding details, any DNS logging. I forget about DNS logging in here as well. So all of those settings could be packaged into one unit, and that unit gets shared, and that unit gets attached to the VPC. If then I make changes or add another private hosted zone or remove records, everything gets reflected in all of the VPCs. So that is the best way to deal with like trying to create a like very distributed view of every VPC being able to see multiple private hosted zones. And then the benefit of that is if I'm inside of this app VPC, I do a query for app1 or app2.loop.internal. That happens to be in the profile, I get the answer back straight away. Lowest latency, no issues with any AZ challenges. There is a cost still that you need to consider. So there's an hourly cost for a profile being associated with a VPC. So that's something that still you need to take into considerations. But those two initial problems that, in some cases, if there's issues, the lack of AZ independence is highly critical. That's a big issue if you're if you really care about your DNS working. Like you don't want to be dependent on another AZ that you don't have any workloads in. And then the latency also super important, but sometimes you can survive with an extra little increase. And then there's caching everywhere else. So I would say the lack of AZ independence was the biggest pain.
So we're getting a bunch of comments on the cost. The cost is not small. It's
Yeah,
cheaper to roll out the changes on all VPCs using Terraform instead of using profiles.
totally. If you can do it in Terraform and you can associate private hosted zones directly to each VPC, that's the way to go. Right, I totally agree. If you want to optimize for cost, you're getting the same experience, a private hosted zone directly associated with your VPC. If you can automate that with Terraform, go for it. I totally agree. This is more if you have a lot more settings and you're not able to like manage that in Terraform, you want AWS to manage the distribution for you, create a package of all of your DNS settings and then associate them with the VPC. And yeah, we'll pass on the feedback on the cost to the service team for sure. Any other questions, comments, feedback?
Um, yeah, I think there's a comment. Oh, Well, let's go with this one. Um, I guess there's a limit on the number of VPC to private hosted zone association as well, which where makes sense because they manage a lot more easily. So I guess the comment here is that if you're hitting that limit of the VPC to private hosted zone association, then the profiles, RC profiles, would scale much better.
Yes, correct. That's another benefit. The profiles actually allow you to scale to larger numbers of private hosted zones being associated with the VPC than just associating directly. I can't recall now off the top of my head what was the. Actually, maybe we can just check what the quota is on the fly. Around 53 quotas. Resolver. Rules. Where is that? Okay, VPCs on a per hosted zone. Da, da, da. Yeah, I think the limit is now how many VPCs you can associate with a private hosted zone. I think that's the limit. So there is no limit on how many private hosted zones you can associate with a VPC. Yeah, so you can have as many private hosted zones associated with the same VPC as you want. But then if a private hosted zone is associated with more than 300 VPCs, that's where you want to start looking at profiles.
One more comment here. Private hosted zone, .3 private hosted zone is global, but profiles it's regional and question mark.
Yep, that is true. So that's a good call out. Profiles are regional. So even though a private hosted zone, let's say that is inside of this profile, and this is, let's say US East 1, that private hosted zone inside, you create it, it's global, but then when you put it into a profile, you have to put it to a regional profile. So if I have another region in US East 2, that would be a completely unique separate profile, but I still could have the same private hosted zone attached to it. So that's a good call out. It's a regional construct, so you have to manage profiles on a per region basis.
Yeah, which could be a good thing depending on what you're trying to achieve.
Yeah, I think probably the private hosted zones are one of the only settings in that profile that are global, because all majority of the other stuff like forwarding, logging, you would be setting up on a kind of regional basis.
Yep. Awesome. I know we are towards the end. I think we have like 5 minutes left. Anything else, Tom, you wanted to share today? I'm just gonna run through and see if there's any other questions which we missed.
No, I think that's all I had. So we covered the inbound endpoints. I think the outbound and inbound endpoints that we talked about, that's pretty much a no-brainer, right? If you have a hybrid scenario and you want to resolve DNS on-premise or you want to resolve private DNS in AWS from on-premise, you use the endpoints and you're sorted. I think where it becomes more complicated is making sure that you can have private hosted zone resolution across your mesh of VPCs. And that's where you either do the association manually, that's the lowest cost, but the highest complexity. But if you operationally can solve that, I would go with that model. But it's only on a very private hosted zone. So then if you have other settings that you need to associate, your logging, firewall, and so on, you'd have to do that separately. The other option is doing forwarding like we've seen here. That comes with still a little bit of operational overhead, but it makes that setup slightly easier, but it comes with other challenges. There's a availability risk with availability easy, lack of easy independence, and you're adding extra latency to the DNS, to each DNS query. There is also some cost, so this is going to be higher cost than using just pure private hosted zone association. And then finally, profiles are regional, but let you create multiple settings together, group them, and share them with every VPC. From a cost point of view, it's a slightly different model because it's an hourly cost compared to this forwarding being there's a number of query costs as well as hourly cost here. So you're going to have to look at the pricing and figure out what makes sense. If I remember correctly, the profile costs kind of is initially higher, but once you get to a certain number of VPCs, I think the incremental number of VPCs don't make that much of a difference after a certain amount of VPCs. Okay.
I was on mute. So I said this is awesome, but we do have one final question. This is based on a very recent announcement. I'm just checking; it was announced yesterday. So I don't know, Tom, if you can speak to it. But the question is: Route 53 resolver endpoints now support DNS delegation for private hosted zones. If you have time, can you just explain what that means?
I haven't played with it, and I just saw that when I was doing a demo. I saw there was an additional option in there. So I can get it to a point, but I haven't really tested the feature, so I can't speak authoritatively to exactly how it works. Ultimately, with private hosted zones, and this is kind of where we build those endpoints, the only option that you normally had was forwarding. So you couldn't traditionally with DNS you can do delegation. So if I have a zone, so say this is, let me see if we have enough time. I don't know if we have enough time. We got 3 minutes left, so might not have time to actually explain all of this. But at the high level, we didn't support delegation with private hosted zones. So all you could do is forwarding. So you couldn't delegate a subzone of your top level domain to another DNS server. I think with the new launch, we're now allowing you to point to an endpoint as ultimately as a name server for a delegation. But yeah, I don't think we're going to have time. We already have a slot next week, but we probably want to come back and talk about that feature a little bit in more detail.
Yep, awesome. And I see we do have a release announcement page and some details around it. So definitely check the documentation, which has obviously this detailed in a lot more detail. So
Cool.
awesome. I don't see anything else. I think we have answered all the questions. If I missed anything, apologies in advance. But again, we'll be back next week with something different. Do you know, Tom, what are we talking about next week?
Yeah. Well, we're updating our page. We're going to have Best Buy. We actually have customer coming in to talk about the Cloud One and SD-WAN integration. So it should be a fun one next week.
Oh, nice, awesome. All right, cool. This was it for us. Thanks everyone for tuning in, and we'll see you next week.
Thanks, everybody.